I'm back at the bench again today. In the previous video, we interfaced with the programming connector on this APC UPS and adjusted the charging voltage. The batteries I've got for it aren't very good. I've got a new tool today to see just how bad they are. This is the Ancel BA-201. It's an automotive battery tester. I picked it up off of eBay for about $40. It's designed to test car batteries for things like the cold cranking amps and internal resistance. I figured it'd be worth a try to see what it'll do with these old UPS batteries to give a general state of health for them. As a comparison, I also have this tester from work. This is the ACT Gold Plus. They don't sell this model anymore. It's several years old, but this one is designed to give you an approximate amp hour rating for batteries like these sealed lead acids. I haven't found it gives a great result. It seems many times it'll tell me a battery is perfectly good when I know it's shot. But we'll do a comparison between this and the other Ancel tester and see which one gives us a more accurate result. In order to give a good test to these tools, I've got a set of 16 old 12 volt 17 amp hour batteries and two batteries which are actually relatively new. All of the old batteries are at least between 4 and 6 years old. They've been sitting uncharged for approximately 6 months, so I'm going to put them in the UPS 4 at a time until it says they're fully charged and let it sit for a couple hours, and then connect each battery to both testers and keep a log of what it says the health of the batteries are. If I can find a set of 4 that both testers agree are in fantastic shape, I'll put that set in the UPS, fully charge them, and see if the testers are accurate and that the UPS gets something close to its expected runtime. For now though, I'm going to put all of these batteries 4 at a time into the UPS, let them charge, and then I'll hook up the tools and see what we see. One thing I found interesting about this tester is it looks like it's got these thick wires that could carry a whole lot of current, but in reality it's just 2 thinner wires. I believe they're doing this in order to eliminate the problem of voltage drop in the wires. They're doing a 4-wire measurement. One of the wires is attached to the outer shell of the alligator clip, and the other is isolated and connects to these teeth. So by doing this, when it's doing any sort of current testing, it can measure the battery voltage independent of any voltage drop there would be in the wires. While my first set of batteries is charging, I thought we'd just go through the tool and how to use it. These new batteries I've got were actually just recently charged. I charged them with my power supply to 13.8 volts, so hopefully they're near top capacity. I'm not going to make a full tutorial on how to use this tool. It's pretty simple. We're just going to do a check here. And since it's intended for cars, it's asking in or out of vehicle, so we'll see out of vehicle. Regular flooded to be a car battery. AGM flat plate is this type of battery, an absorbed glass mat. We don't have any sort of like amp hour or watt hour capacity with this tool. About the closest we can get is crank amps, which according to the battery manufacturer for this, which is CSB, the maximum current this battery is rated to at a 5-second is 230 amps. So we can set that here. I'm planning to test a whole bunch of different batteries like this. For example, these are 17 amp hour. We also use a lot of 7 and 9 amp hours and 12 amp hours. And even if this isn't a real good rating, this crank amp, at least to sort of get a baseline by testing a whole bunch of new batteries versus old used batteries versus batteries that just don't work right anymore. Maybe using this tool I can get sort of a baseline to compare when I have some batteries that are suspect to see if they're any good. But in this case we'll proceed with a 230 amp rating. And it gives us a 100% state of health. It looks like it believes there's 236 amps and 12.75 volts. The resistance it's measured is 13.17 milliohms. The manufacturer again rates these at approximately 14. So this battery appears to be in good health and good shape. It's ready to go out in use. I'll do the same after charging all of these other batteries I've got. I'll run this tester on it and see what we get. And this is the other tester I've got, the Gold Plus. This one is supposed to give you an approximate amp hour rating. That rating, as the manufacturer specified and as this tool test, is a 20-hour battery rating. In a typical use for a UPS, you're never going to be running 20 hours on a set of batteries. It's 20 minutes would be more likely. So I don't expect to actually get the capacity that any of these tools say, or that perhaps the battery manufacturers say are going to receive, because we're discharging them at a rate much faster than what they've rated them for. But for this tool, we just have to connect to the battery here. It powers up, and then it's going to give us a voltage rating. Okay, it's said 12.82 volts. Press to test. To the test button. Its best guess is 14 amp hour. It's a 17 amp hour battery. It's maybe a year old. I don't know if that's anywhere close to accurate, but certainly better than a lot of the batteries I've tested. I'll run both testers on all these batteries after fully charging them, and we'll be back with results. All right, I'm here at the computer looking at the results I gathered. Both testers seem to agree that number 5, 7, 8, and 14 are the best batteries of the bunch. So what I'm going to do is take those 4, make them a set, put them in the UPS. I'll let it charge overnight and then run a load test. As a test load this time, since this is in my basement anyway, I'm going to run my dehumidifier. It's certainly not the sort of load that the UPS is designed to handle, but once it's running, it seems to do just fine. I'd rather not burn off all of this stored energy as heat. It is summer here, and I need the dehumidifier anyway. According to APC, for my dehumidifier, which I've measured at about 560 watts, this UPS should be able to run it for 44 minutes. That is, of course, with brand new batteries. I'm going to run this one set of 4 that I found, according to our testers, are the best. We'll see how long it lasts, and we'll have some results in a minute. The load test is complete. I had a script running polling the SNMP management board in this UPS for the amount of time it believes is remaining, the percent capacity, and the battery voltage. You can see we only got about 18 minutes of runtime of the 44 we were hoping for, and there's an interesting drop around the 12-minute mark. I'm guessing that this is actually indicative of a bad cell. I went through the 4 batteries, and before they had a chance to recharge, tested the voltages on them again, and found that one of them had actually a much lower voltage than all the others. It was around 10.5, where all of the others were above 12 still. So what I'm going to do is swap that battery out. That was number 5. I'm going to put the next best one in, which is number 13, and do it all over again. We'll do a full charge, leave it sit for a few hours to equalize, and then run the exact same load test again and see how our results compare. Here are the results from the second load test. This time we got about half an hour of runtime. You can see from the discharge curve that this is much more like what you would expect to see versus the earlier one, which had a sudden drop halfway through. As the batteries near exhaustion, you see them drop off precipitously, but it's a nice smooth curve from within a few minutes after start to their eventual depletion. So what's the final verdict? Which one of the testers gives us a better overall result? In my opinion, neither of them really gave us an accurate result. According to both testers, number 5 was better than number 13. The Ancel said it had a higher amp capacity, a lower internal resistance, and the ACT tester had one of the highest amp hour ratings, when in reality, under a true load test, it died early and appears to have a bad cell. Both testers do seem to be able to spot a battery that is definitely bad, between a high internal resistance, a low amp capacity, or a low amp hour rating, but batteries that test as good may actually be bad when placed into a true load situation. It seems to me that this would be a good way to weed out the definitely bad batteries from the potentially bad batteries, but you really have to install the batteries, charge them up, and do a load test to find out which ones will really go the distance and which ones appear good, but when pressured into service, actually fail. Not sure if I'll do any further testing on this. That's all for now.